Hey everybody, it's Mr. Carr again. Today we're going to be talking about 4-7 transformations of quadratic graphs. To help us understand those transformations, we're going to look at a slightly different version of our quadratics. We've actually talked about factored form and we've talked about standard form. This is vertex form. It gets its name because you can see the vertex from these two values. So x minus h is actually going to be like the h and k is my vertex. So you notice it's opposite if it's negative h in the equation, it's a positive h here. Okay, so for a quick example, if I say y is equal to x minus 2 squared plus 3, my vertex is at the point positive 2, positive 3. Okay, a does the same job it does before. If a is a positive number, the graph opens up, so it looks like this. And if a is less than 0 or negative, it opens down, so it would look like this. So those transformations are going to help when we kind of analyze, for example, right here. Okay. We want to first, before we can kind of describe what's happening, we want to first turn this into vertex form. Okay. Then we'll be able to identify the vertex, the axis of symmetry, and the direction opening. So we want to complete the square to switch it from standard to vertex. Now, normally we do a complete the square, it's equal to 0. In our purposes here, we're going to change it up a little bit. So I'm going to keep it as y equals. We'll have x squared plus 4x. I'm going to leave a space here. Oops, and then I'll have the plus 7 and leave a space here. I'm going to still do the same process. So I look at my 4, my b value. I'm going to take 1/2 of 4 and square that. So that's going to come out to 2 squared, which is going to come out to 4. So just like completing the square, I would add 4 here. Normally, we would add 4 to both sides. But this case, I want to keep it all together on the same side because I want to turn it into vertex form. You notice how we have this k value after all this. So I want to keep it all together. So to do that, I'm actually going to subtract 4 at this spot. That way I'm adding 4 and subtracting 4, just doing it at different parts of the equation. Now this part can go through my factoring. So y is equal to x plus 2 squared. And then I can put the 7 minus 4 together and I get a positive 3. So now I have all the information I need. The vertex, it goes opposite that positive 2, so it's a negative 2. And then a positive 3. My axis of symmetry, remember it passes through the vertex, so it has to match up to the x value. So I write it as x equals negative 2. Okay. Direction opening, since this is a positive 1 for the a value, it is going to open up. So we know it's going to look roughly like that. So since I have my vertex, I'm going to go ahead and plot that. So I got negative 2, positive 1, 2, 3 is right here. Okay. So remember, I need one more point, and I can use my symmetry. We'll go back to the original problem. Remember, I got a positive 7 there. That's my y-intercept. So without doing any other any other work, my y-intercept is at the point 0, 7. So 1, 2, 3, 4, 5, 6, 7 right there. Okay. From there, thanks to symmetry, I'll put that right there. We'll go 1, 2 from here. So then I'll go 1, 2 over here. So the point negative 4, positive 7 is also on this graph. And there's my quadratic. Okay. So when we talk about transformation, it's transforming from y equals x squared. I'm going to do that real fast here as y equals x squared. That looks like this. 2, and then 1, 2, 3, 4. And then 1, 2, 3, 4. This is y equals x squared. So what you can see is that is shifting left and right. What's happening is it goes left 2, up 1, 2, 3. You could just focus just on the vertex here. So it moves left and up for that transformation. Okay, so another one. We got y equals negative 2x squared plus 8x minus 3 in vertex form. We'll do the same thing. We identify the vertex, axis symmetry, and the direction of this opening. Okay, so first thing we want to do is isolate the terms with an x variable. So I've got y equals negative 2x squared plus 8x. And then I'll keep that a little bit separated, but plus something plus, or sorry, minus 3 plus something. From these two terms, I want to factor out the Lie coefficient. Okay. So instead of dividing out the Lie coefficient, we're going to factor it to the front. So it looks like this: -2 times x squared. Then I'm going to take out a -2 from 8. It's going to give me a -4x. Okay. And I guess I put these pluses up here, but that didn't really matter. I'm going to get rid of that now. Okay. I'm really just focusing in on this part because now I do my factoring. This is where I'm going to put my plus blank. Okay. So then I still have the -3, and now I'll have a plus afterwards. Okay. Add a space times the Lie coefficient outside the parentheses. Yeah, I think, okay. Fill in the space, factor and simplify. I'm a little confused by this step by step here, but basically what we're going to do is we factor this right here, but I want to leave the space where we normally would add in for completing the square right here. So I do that in my normal process. So I'm going to have 1/2 of -4, and then I square that. So that's going to turn into 1/2 of -4 is a -2 squared, which is a +4. So that's what's going to go here, +4. Now, the thing to remember is this -2 is technically distributing with 4. So that means that is -2 times 4 is -8. Because that's a -8 there, I'm going to add 8 here to balance it out. So I want to make sure that there's still that whatever I'm adding into this section is being the opposite added over here. So it's still the same overall in the end. This can now do my factoring. So I'm going to have a -2 in front. This will turn into x minus 2 squared. And then a -3 plus 8 is going to give me a +5. So vertex is at a +2, +5. The axis symmetry has to match up to the x value, so that's x equals 2. And the opening, because A is a -2, it's going to open down like that. Okay, so, and again, for my purposes of graphing, I recognize that I have my y-intercept is at 0, -3. So if I come here to my graph on this one, I'll go to 2, 5, 2, 3, 4, 5. Here's my vertex. I'll graph my axis symmetry there, so x equals 2. Okay, my y-intercept is at 0, -3, so 1, 2, 3 right here. And then thanks to symmetry, I'll go 1, 2, 1, 2. So that is 4, -3. Okay, and there it is. So that's how my graph changes from that one. Again, remember how it changed? This is the initial one. We're moving it to the right, we're moving it up, we're reflecting it, and then we're doing something else called a stretch, but we'll talk about that if we need to in the future. Okay, so the last thing I want to do is how do we write the equation given this graph here? So we're going to start with vertex form. Remember, the vertex is at h and k, which in this case is at the point 2, -3. So when we write that in, we would write y is equal to a times, we do x minus h. So if it's a +2, this will be x minus 2 squared, and then plus k. Well, k is a -3 here, so I'm going to subtract 3 at the end. Now, the only thing we don't know is the a value. So if I want to determine a, we're going to substitute from the point, another point that's from the graph, x and y, and that'll help us solve for a. So 0, -1. So -1, feel that a times 0 minus 2 squared minus 3. Okay, pause it real quick. Okay, sorry about that. All right, so if I go through my order of operations, I'm going to take care of 0 minus 2 here. So that'll be -2 squared and then minus 3. Okay, and then I'll just kind of do it right over here. So we got -1 is equal to -2 squared is going to give me a +4a minus 3. We'll add 3 to both sides. So that's going to give me a +2 equals 4a. And then divide by 4, and I get the fraction for a is 1/2. So I have enough to do the entire equation now. It's going to be y equals 1/2 x minus 2 squared minus 3. So again, use the vertex, put it into vertex form here, use another point that's on the graph, and plug that in for x and y until you can solve for a. And now we have all three of them, a, h, and k. All right. And that is it for our transformations of these graphs. So we're, again, transforming from standard into vertex form. We're also taking a graph and turning it into vertex form and making sure we find all of our a, h, and k values. That's it for today. Take care.